for average atomic mass or atomic weight. Okay, now this is a situation. So the first one, the isotope chlorine 35, we call atomic mass 35, and chlorine 37, atomic mass 37. However, from periodic table, atomic mass of chlorine is 35.45. So if you recall your memory about SPM, sometimes we learn about carbon 12, carbon 14, oxygen 16, oxygen 14. So this is example like chlorine 35, atomic mass 35, and then chlorine is atomic mass 37, right? So this is the mass of isotope. But in your periodic table, see, periodic table, they won't jot down chlorine the mass 35, 37, but they will write now 35.45, or some of book were using 35.5. So why they didn't write atomic mass in periodic table with 35 or 37? So the first question, how to determine chlorine exists isotope Cl35 and Cl37? So what kind of machine to determine different atomic mass of isotope? So we are using the machine we call mass spectrometer. Number 2, why the atomic mass in periodic table is different from the data given? So why periodic table we using 35.45 but not 35 and 37? So we'll answer this question from the mass spectrometer. Okay, now look, this is a mass spectrometer. Mass spectrometer to determine type of isotope. So mass spectrometer is modern technique to determine the first one, relative isotopic mass. They can know the mass. Number 2, relative abundance for isotope in a sample of element. Abundance here meaning that, let's say you have a carbon 12 and carbon 14. So percentage the carbon 12 exists in this world is higher than 14. Let's say carbon 12 is 99% and carbon 14 1%. So how we know this percent? So how we know this percent? This percent we call abundance. So how we know this percent? We know this percent from the machine called mass spectrometer. So number 3, we can determine the relative atomic mass of the element. Yeah. So number 4 is relative molecular mass of compound. Okay, this is a machine. First one, they have vaporized a sample. So you will form ionization sample. So this is a machine. So in this machine, they will form 2 ion. So first one is 35 Cl plus, and the second one is 37 Cl plus. So these 2 ion here. So these 2 ion will pass through the acylation. Acylation is spit out the positive ion, and this part, second part, is a diffraction. They will do diffraction based to the mass over charge. So the mass of 37 is higher, so the corner you will go straight, and then at diffraction they will spread by 2. So the higher mass is 37 Cl plus, the diffraction less is 35 Cl plus. Then this is detection. So detection is here. So they will continue with the computer PC. So they will fall down with the detection. So after detection, they will come out. PC will record the 2 data. First one is relative abundance. For the second one is isotopic mass or mass over charge. So let's say 35, they will record 35 Cl. The percent may be higher. So their abundance will higher. So 37 Cl, the percentage lower, so the peak will lower. So this is this one we call mass spectrum. So this is outcome of the mass spectrometer. So for the next slide, we'll learn how to interpret this mass spectrum. Now this is a result atomic mass and abundance record as mass spectrum. So mass spectrum is a graph intensity of detected signal versus ion atomic mass. So intensity here is meaning that percentage of isotope exists in this world. Okay, now let's say the mass spectrum 1, so they can using percentage of a mass. So the y-axis is represent amount of isotopic air axis, so they can be jotted down as abundance, percentage abundance, or ratio. So the unit for the y-axis can be using percent or no unit. Unit means they're using the ratio. Okay, so this is they're using this one is relative. Okay, now relative burden. Okay, let's for just now y-axis, now is s-axis. S-axis is all isotope with specific atomic mass. So let's say for carbon, inside got 2 isotopes, so they will exist 2 isotopes. So the meaning is they're using mass over charge or isotopic mass. For isotopic mass, usually they'll give you AMU. So unit of atomic mass or AMU or U. Okay, let's say here, this one is 35 chlorine and this 37 chlorine. So mass over charge, 35 chlorine, 37 chlorine. So for the abundance, they can jot down the peaks like this. Yeah, so this is 35 chlorine. The abundance is this part, 35.78. For 37 chlorine, the abundance is 24.22%. Okay, maybe you ask why you have two mass. One is 37, one is 36.966. So 36.966 actually is a more accurate mass. Okay, so sometimes the mass spectrum also can just jot down like this, just a high peak is a peak also can. Okay, now we scroll down. So now activity 3, complete the table below based on the mass spectrum in figure 1. Okay, now we can do the discussion. For this is 37, percentage 75.78. So for 37, the abundance is 24.22. So this percent, that means all will become 100. So for the ratio for 35 Cl and 37 Cl, so actually we can do the comparison like this. Let's say 35 Cl versus with 37 Cl. So is you get 35.78 over 24.22. So you will get the answer is 3.129. So 3.129 is you learn as mathematics, right? 3.129 over is 1. That means that you can draw your mass spectrum. So this is a 35 Cl. The ratio is 3.129, and 37 Cl, the ratio is 1.0. So this is meaning right ratio.